Hello everyone. Today I Suryansh Singh is going to give you differences in protection and security module of Windows OS and xv6. Let's get started. Difference in protection of xv6 and Windows OS. Windows provides authentication, that is it verifies user identity and only after that grants permission to access the operating system. This feature is not provided by xv6. Newer versions of Windows also have multi-factor authentication. Windows provides authorization, that is, it decides whether a particular user is allowed to perform a function or not. Authorization is not possible without authentication, therefore, xv6 does not have this feature. Windows provides user administration, that is, it allows users to create user accounts and grant privileges. Without authorization, user administration has no use, and therefore, it is also not provided by xv6. Differences in security of xv6 and Windows OS. Windows provides a software firewall, while there is no such provision in xv6. A firewall checks for malicious softwares and prevents them from entering our system. Windows has provision to encrypt our files so that if some hacker enters our system, he or she cannot extract the real data. This feature is unavailable in xv6. Windows routinely checks for bugs and tries to resolve them, and if some updates need to be done, then it sends a hotfix, that is also known as a patch, to resolve them. There is no such feature in xv6. Two features of Windows OS that are not in xv6 are: first, authentication. There is a proper GUI based login feature in Windows where GUI stands for graphical user interface. Second, authorization. Authorization in Windows can be achieved using ICACLS command in command prompt. So first we will try to implement authentication, and the plan goes like: we know that init process is the first process that is created by xv6 upon boot up. Therefore, we will implement login feature here because authentication needs to be done before anything else is possible. The instructions which are already present in this file are very important and must be executed also. For authentication, we first need to create users. We can store username and password of users in two ways. Either we can store them in file and use file manipulation capabilities of C language to authenticate, or we can store username and password of users in the init file itself. So firstly we will run the sh program, which is responsible for controlling the CMD. After setting the CMD right, we will ask the user for their credentials and we will try to match their credentials. If they match, then we will grant access and run further init code. If the user fails, then we need to give them another chance. Therefore, we need to carry out authentication in a loop. That must be an infinite loop. And if it matches, then we break the loop, else we continue to be in the loop itself. Init user function, which uses init system call, will work as logout function and will ask for authentication again. Therefore, we need not code the logout part, it is already there. Authentication implementation. In init.c, store username and password as global strings in arrays outside the main function. Now inside the main function, let sh program run, and then after that, check if the PID is equals to 0, because we only want to run it in the parent process, not every time we want to run the authentication thing. If yes, then run an infinite loop having while 1, and inside the loop, ask the user to input username and password. Call the function login with parameters username and password. Then implement this login function, which will try out to match username and password with many usernames and passwords we have in the global strings. If any pair matches, return 1, else return 0. If returned 1, break the loop and welcome the user, else continue running in the loop. Now, after authentication, we will implement authorization and user administration for file implementation. And the plan goes as: for authorization, authentication is a must. That is, we need to remember who the current logged in user is. And we also need to remember the owner of every process and file. We will do it in init process, that is PID is equal to 0, as it is the ancestral process of every other process, and we will add the same functionality in fork function, using which every other process is created. For user ID, we will use the index of global arrays, which we created in the previous implementation. We also need to store permissions for other users other than the owners and give default values to them. Now, while opening any file, we need to check the permission of the user and act accordingly. We need to make a system call to change permissions of users, and then we need to create a user program which can call the system call and can take command line arguments. Note, we are only considering read-write functionality here. We are not considering execution. Authorization for file permission implementation. In proc.h, inside process structure, struct proc, add integer variable UID. This integer variable UID will store the owner of the process, and for storing that, in init.c, after the username and password have been matched, add that index in the UID variable. That is, this UID variable will be initiated with the index at which this password and username have been matched in the global array. Now in proc.c, in fork function, initialize child UID as parent UID. In this way, all the processes have their owner. And now in file.h, inside inode structure, add integer variable owner and 2D array permission of length equal to number of total number of users. This owner variable will store the owner of the file, and this 2D array will hold the permissions. The first row will hold the read permission and the second row will hold the write permission of all the users. In sysfile.c, inside create function, initialize the permission array with default values. We have taken the default values as giving access to everyone, that is store 1 in all the row and columns of the permission array. In sysfile.c, in sysopen function, check if the omode is equal to read only or read write. If yes, then check the permission for user. If check the permission that if the user has reading permissions or not. Similarly, check if omode is equal to write only, read write, or create. If yes, then check permission for user, that writing permission of the user is there or not. If any of the tests from above fails, then return -1 and abort it, else continue as normal. User administration for file permission implementation. To make use of system call chmod, we will create a user function which will call this system call chmod and can take command line arguments as the file whose permissions are going to be changed, username of the user whose permission are going to be changed, and the new permissions for him or her. To make system call chmod, do the obvious entries in usys.s, user.h, syscall.c, syscall.h. In sysfile.c, create function integer syschmod void. First check if the current user is the file owner or not. Because if the current user is not the file owner, then he or she should not be allowed to change the file permissions. So if they are not the file owner, return -1 and abort, else continue. Also check that the new permissions are greater than equal to 0 and less than 4, because we want to make them only have 2 bits and not more than that. So if not, return -1 and abort, else continue. Now take arguments in file pointer f, integer UID, this will contain the UID, and integer user permission, which will contain the new permissions, and then make changes as in permission array. This 0th is for reading. So at in reading, take user permission by 2, and at writing, take user permission mod 2. So we are here we are saying that in the permissions, the least significant bit represents the writing permission, and the most significant bit, that is the second bit from write, represents the reading permissions. So accordingly, we can fill the entries in the permission table. Thank you.